In the United States, we've known for years that certain species of mycoplasma, like Mycoplasma pneumoniae, which causes respiratory pneumonias, most people considered it fairly benign, but other people, like pediatricians, knew that this could cause a very serious disease process and even a fatal process in certain children. Most people didn't know anything about some of these other species of mycoplasma. The one that we actually found in the Gulf War veterans was this unusual species, Mycoplasma fermentans, which had only been described a few years earlier and described by this U.S. Army laboratory in Washington, D.C., at the Armed Forces Institute of Pathology. We know that different types of mycoplasmas appear in frequency in different populations. For example, in Europe, people that have chronic fatigue syndrome, they also have mycoplasmal infections. There, the most common mycoplasma is Mycoplasma hominis, whereas in the United States, people that have chronic fatigue syndrome, the most common mycoplasma turns out to be Mycoplasma pneumoniae. In the US, we also see quite a substantial number of these also have Mycoplasma fermentans as well. We don't see that as much in other parts of the world, but it acts like a parasite. It enters cells, and once it's inside cells, it steals things from the cells to help it survive, proliferate, and function. It exists inside the cells, and then because of that, it screws up some of the machinery of the cells in the process, and that leads to the disease process in itself. Part of the disease process is because the immune system is trying to find this type of unusual infection and it's having a hard time doing it. And the other thing is, when these bacteria are inside the cells, they cause a number of problems in the cell. And in particular, one of the problems they cause are with the mitochondria inside the cells. The mitochondria are little batteries inside each cell, and these little batteries provide the energy for life. They provide the energy that's necessary for a cell to survive and function, divide, grow, and so on. And without the mitochondria functioning properly, cells will die. The mycoplasma does interfere with the mitochondria and does interfere with other functions of the cell as well. That's how the cells kind of get screwed up by having these mycoplasma present inside them. There are other things that the primitive little bacteria, subbacteria, things that they do. For example, they produce certain toxins that interfere with cell function. Besides stealing metabolites, they also have certain enzymes that they produce which interfere with other things in the cell, other structures in the cell, other enzymes in the cell. They don't want to just kill the cells outright. They want to keep the cells alive so they can proliferate. And it really depends on the individual where you show certain symptoms. People that have arthritic symptom, this generally means the mycoplasma are in the joints. Other individuals have pneumonia because of it. In childhood, atypical pneumonia is commonly caused by mycoplasma. In some people, this can cause gastrointestinal problems. In other people, it can invade nerve cells. We often find these types of infections in literally half the people that have fibromyalgia or more, sometimes up to 70%, 75% have this type of infection. We see this also in neurodegenerative diseases, and some more than others. For example, in one of the neurodegenerative diseases that we've studied, amyotrophic lateral sclerosis, ALS, or Lou Gehrig's disease, which is a degenerative disease of the central nervous system that basically people become slowly paralyzed. They're often associated with other bacterial and viral infections as well. This type of infection can reactivate them, or if you have the mycoplasma and it becomes inactive or latent or chronic condition, which is just smoldering, and you get, let's say, a viral infection, it can trigger it again. It can all of a sudden take off and become very active again. And they do require cholesterol and they can't make it themselves. So they reside in tissues and cells that make a lot of cholesterol so they can grab those cholesterol molecules for themselves. And they do it in a way, if the cells are making a lot of it, they can steal some of it without killing the cell. These are generally infections that become system-wide or systemic, but they tend to favor certain tissue. And these are tissues that have the molecules that they need to function, cholesterol being one of those molecules. Most of your general practitioners don't think about mycoplasma as an important infection. And that's because in medical school, they're taught that in general they're benign infection, if they're taught that at all. And I know this because for over 25, 30 years, I taught in medical school. So I have a pretty good idea of what has been taught to medical students over the years. And over the years, they've been taught that this infection is rather benign, it's not serious, that you can have this superficially, for example, in your oral cavity, your sinuses, and so on, and it doesn't even cause symptoms, and it's nothing to worry about. Well, that may be true in a superficial sense, but if it does invade into your system, that is, it gets into your blood somehow and gets into your various tissues internally, it can cause difficult problems. We often don't find mycoplasma by itself. We find it with other bacterial infections, such as Lyme disease, even parasitic infections, or in viral infections, where viruses, along with mycoplasma, play a role in the infectious process. It's often present as a co infection. Chlamydia pneumoniae is often found with mycoplasma as a co infection, for example, not always. We found it in autistic children, for example. We found it in chronic fatigue syndrome. And so you start to see mutation in the DNA. And eventually, with the mycoplasma there, some of those cells actually progress to transformation and they're transformed cells, which look more like cancer cells than normal cells. And some of them even progress further on and become tumorigenic. And if you put them in animals, they cause a type of cancer in animals. Then we found almost one half of the veterans that we tested had this type of infection. The most interesting thing was if their children or their spouses became ill after they returned, they were showing the same infection. So we thought, well, this has got to be the key element here. And the other thing was is that they slowly responded to the treatments that you'd use for the particular infection that we found, mycoplasma. When we sent a little note to the JAMA, the Journal of the American Medical Association, on this, all of a sudden you would have thought that, well, people would have been interested in this, but instead I got attacked. My wife and I at the time, my late wife, we were both attacked very severely for what we were doing. That just didn't make sense at all. What we found was something that we were not supposed to find. We found an infection. Turns out, after looking at this in some detail, what it seemed to relate back to these people who were being deployed, these veterans who had been deployed in the Gulf War, had received a number of different vaccines before they were deployed. Most of them got many vaccines. Usually they got them almost all at once within a 2 or 3 day period during their deployment. For anybody that knows anything about vaccines, this is very immunosuppressive to get these vaccines all at once. And so I thought, well, maybe this could have been a contaminant in the vaccines because turns out mycoplasma is actually a very common contaminant in commercial vaccines. This has been seen in veterinary vaccines, it's been seen in some human vaccines, but most are not even checked for this type of contaminant. Meanwhile, while all this was going on, there was quite an effort going on to shut down this research, to stop it. There was a lot of pressure put on the institution. At the time, I was department chairman at the University of Texas in Houston, the MD Anderson Cancer Center, and a lot of pressure is being put on the institution to shut down this research and even shut down my laboratory. At the same time, we were being attacked publicly, we were being attacked professionally, and it just didn't make sense at all. It's an issue that I think the VA doesn't want to face, the DoD doesn't want to face directly, because it has a lot to do with the way they prepare their forces, and it has a lot to do with liability. It has a lot to do with political consequences of the decisions that were made before the Gulf War. And eventually, I left the MD Anderson Cancer Center. We moved back to California, where I was from. I was previously a professor in the University of California system before I went to Texas. Came back to California and formed a nonprofit research institution so we could continue, at least in part, some of this work, also continue on the cancer biology and normal cell biology research that I was conducting in my laboratory in the first place. Now I've been retired for over a decade. I still work, I still run clinical trials, I still do some things. I've gotten involved in this coronavirus routine. We were seeing a lot of arthritic signs and symptoms. We were seeing a lot of gastrointestinal problems. We were seeing a lot of neurologic problems. And so there are only so many different types of infections that can cause all these different problems and yet not be acute, not cause severe immediate problems. And mycoplasma kept coming up positive. If, for example, cell lines are used in the process of making the vaccines, often cell lines get contaminated with mycoplasma. It's a very common occurrence in any laboratory that carries cell lines. People couldn't go back after the Gulf War and find out what vaccines did they actually receive. At the time they were being vaccinated, shop records were being confiscated. They weren't being entered into the record, or if they were, the records were being confiscated. There was one study being done in Kansas, for example, by a state epidemiologist who studied Kansas veterans, and they studied veterans who were deployed and vaccinated. So they started studying all those. They found out that this disease process, this Gulf War illness or Gulf War syndrome, it was being called, was associated with the veterans who were vaccinated and deployed. We provided some of the original documentation for mycoplasma and autism because we studied autism. And we got involved in this, really started with the Gulf War, because when the veterans came home to their families started to get sick. And the adults were showing signs and symptoms similar to the veterans, more of a chronic fatigue syndrome type of illness. But the children were becoming autistic. And so that led us to look at autism. When we looked at civilian populations that had nothing to do with the military and no connection with the military, but had autism, we started looking at those children, and we found that there was a fairly high percentage of those children that had mycoplasmal infections. It's a very common problem with gut disorders and causes some of the problems that are associated with leaky gut syndrome, as it's called. We'll just call it leaky gut, where you have this process. That means your gut is not totally sealed off. Certain components leak in from your gut, and some of those components are very antigenic. When they leak in, they cause a massive host response, and this causes a autoimmune type of situation that's set up and causes many of the symptoms that we see with people that have these chronic gut problems. Many of the patients that we've looked at that had either IBS or Crohn's were positive for mycoplasma. Luc Montagnier was well-known microbiologist. Most people attribute him to as a discoverer of HIV-1. So he'd been studying HIV, and he came to the conclusion that it wasn't the HIV-1 virus that killed people. It was really the co-infections that went along with HIV-1. And one of the important co-infections, it turns out, was mycoplasma. They found Mycoplasma penetrans, Mycoplasma fermentans. These were the types of mycoplasmas that were associated with the lethal form of HIV. So you can have HIV and go on and live a totally normal type of life, even though you're HIV positive, and never have it kill you, never have it progress to a lethal form. Or you could be another patient and have a slowly progressive lethal form of HIV/AIDS that kills you. Montagnier had proposed that the difference between those two is mycoplasma. The people that progressed to the lethal form of HIV/AIDS had mycoplasma. Those that did not have the mycoplasmas. They love endothelial cells, which are the cells lining the blood vessels. They love nerves. Both those endothelial cells and nerves are very much involved in heart disease and nerve transmission problems and so on that cause coronary problems. Do people with heart disease have some of these same problems? Yes, they do. But are they susceptible to problems associated with these types of infections? Yes, they are. These infections can cause problems in nerve transmission, in endothelial cells, and so on. Endocarditis is a major problem in heart disease. That's an inflammation of the endothelium of the heart. Nerve transmission problems, yes. Arrhythmias are often associated with heart disease. Some of the things we've been working on is how do we enable the host to recover from the infection? How do we help them resist the infection? How do we help them recover from the infectious process? One of the things that we've been working on is what we call membrane lipid replacement. We know that a lot of the damage that occurs, and we're talking about damage in the respiratory system, damage in the endothelium, in the vascular system, damage in the brain, in the nervous system, and so on, is damage to the membranes of the cells in those organs or those tissue systems. So we've worked on what are membranes, what are their structures, how do we repair those structures if they're damaged, how do we prevent those structures from being damaged by things like infections or other chemicals or other insults, physical or chemical, that cause damage to our systems. Some of the anti-aging properties of membrane lipid replacement are directed at that. We use, for example, hydrogenized water to prevent inflammation and to help return cells to a more normal redox balance. We know from Lyme disease that mycoplasma is an important co-infection. People that have looked for this have found mycoplasma in the most severe COVID-19 patients, the ones that are in intensive care. We just published a paper on that, which is just out now. The paper was, does COVID-19 progression to a fatal disease require another type of infection? We put in for mycoplasma. Most of the people that probably get the SARS-CoV-2, the virus that causes COVID-19, they probably already have the mycoplasma in a latent form or inactive form inside their bodies already. It's really a matter of activating that to cause a progressive disease process. We think the people that are being hospitalized and put in intensive care units are people that have a perfect storm of not only the SARS-CoV-2 virus, but some of these other bacterial infections as well. Maybe in latent form, maybe they're activated by the virus, but the whole process of having these multiple infections is what leads to their demise, not any one of these infections alone. I was at the University of Texas. I was a professor in the medical school, and I've also run a department at the MD Anderson Cancer Center. And we were noticing that a lot of the patients who are coming from East Texas had infections that were very similar to what we found in the Gulf War veterans. And a lot of these patients were coming from small towns in Texas that turned out to have prisons. And so people in the prison system that were employees were looking at some of the news reports and so on, were following us because they said, we're having symptoms similar to what Gulf War veterans were going through. We wonder if it's related. They contacted us. We tested them and they were positive. They were having all sorts of problems. Yes, they had gastrointestinal problems. They had neurodegenerative problems. For example, in one small town that had 3 prisons in East Texas, people coming down with Lou Gehrig's disease, ALS, which is a fairly rare disease, or at least uncommon disease, but you don't see it in epidemic numbers in certain locations. It's like they were having an outbreak of ALS, Parkinson's, and other neurodegenerative diseases in one small little town, which is very close to the prison. And so when we were trying to help these people because they came to us, we found out that for the most part, these people were either prison employees or family members of people that worked in the prison system. That really rang bells about what was going on in the prison system that account for this. It turns out there were people high enough up in the prison system, in the administration of the prison system, who were getting sick. They were quietly telling us that there's experimental vaccine testing going on in the prison system, some of it being sponsored by the Department of Defense. Turns out they were using prisoners as guinea pigs to test certain military vaccines that they were working on and so on. This is secondhand information that we got from prison employees, some of which were very high up to the level of an assistant warden, for example. His family members became sick, and his daughter came down, was diagnosed with ALS. It was what we call atypical ALS. It was not a complete diagnosis because she was quite young. She was a teenager. It's unheard of for a teenager to get ALS. This is usually an adult onset or middle age onset disease process. It's extremely, extremely rare to find it in a teenager. And yet here we were in a small little town. We had younger people coming down with the diagnosis of ALS. That's how we got involved in looking at mycoplasma because it's something we were testing for anyway. So this is the first thing we tested for. And sure enough, they came up positive. It's an intracellular infection, so it hides inside cells. If you take a blood sample, the only cells that might hide this are the red blood cells or the white blood cells. It turns out most of the mycoplasma are in the white blood cell fraction in the blood. So often this gets discarded in analyzing for infectious material. The best way to test for this is to use a molecular test to test for the actual DNA or RNA associated with the infection, the unique sequences, let's say, of the DNA of the mycoplasma. That's probably the most sensitive and specific test you can use. We've had patients that have recovered completely from a mycoplasma infection, and then years later, they get in an automobile accident, all of a sudden the same manifestations of their symptomatology, they have reborn mycoplasma infection. Project Daylily was the book that my late wife and I wrote to discuss the whole thing that we went through and how it evolved. And we thought that this would be important for people to see what happened, the details behind it. Early on, we were warned about this, that if we tried to produce a book, we would be sued, we would be taken to court, our book would be embargoed. In fact, when we first started approaching publishers, they didn't want anything to do with it. They knew that this was a hot potato to deal with it, so they didn't want to deal with all the problems, the political problems associated with it. So we decided that we would probably have to self-publish this to have any chance of publishing it at all. They can go to the website. I have a Facebook page. They can go to that. They can go to our website. It's immed.org, imed.org. They can drop me an email. I'll be glad to send them information. It's a pleasure to be on your program.